at the question, they give us 3 molecules: H2O, ammonia, and methane. So the question asks for two answers for each of the molecule, and that is the Lewis structure and the shape of each molecule. First, we write down what are the molecules we have to write for: H2O, NH3, and CH4. What I like to do is we have to know how much is the valence electron for each of the atoms. So oxygen, we know we have 6 because it's located in group 16, and hydrogen only have 1 valence electron. But if you look properly, hydrogen have 2 atoms here, H2. So we just have to put 2H here equals to 2 for 2 atoms, times 1 for 1 valence electron. Hence we get 2. And we just add both of these together, 6 plus 2, we have 8. So the next step is to draw the skeleton structure. And we know since we only have oxygen you only have 1 oxygen, and hydrogen cannot be considered as the central atom. Oxygen must be in the center, and so we draw like this: O, H, H, H2O. But bonding pair uses 2 electrons. It's not the textbook term, but it's what I like to go for. So since guys is 2 bonding pair, is 2 times 2 equals 4, and in total we have 8 electrons. So we just have to minus 4. So the valence is 4 electron. Where does the 4 valence electron go? We make it as a lone pair. So that means we have 2 valence electron. 2 lone pair electron. Alright. So 4 minus 4 equals 0. So this is the the perfect one lah. The perfect configuration. Why not make it like this? 2 hydrogen, 2 bond, double bond, It's because hydrogen can only have 1 electron, not 2. Okay? Hydrogen only have 1 valence electron, And we have draw the Lewis structure. The Lewis structure is this, and state the shape. State the shape is V shape. Next, for NH3, we draw the same thing. We do the same thing. Let me write it down. Is that first, write the formula. Next, know the valence electron. 3, draw skeleton structure. And 4, draw the remaining electrons. So if we stick to this four of these, what I say, my rules, right? My style is first we write the formula. Since it's given NH3, we don't have to think much about it, so we just write NH3. Next, know the valence electron. If you don't remember where nitrogen is located, which group it's located, you can just refer it to online. But on exam, if I'm not mistaken, they will give the periodic table lah. And hydrogen, since it has 3 hydrogen, we just have to write hydrogen 3 times and then equals to 3 times 1 equals to 3. We just add 5 plus 3 equals to 8. Hence, total of electron is 8. Step 3, draw the skeleton structure. So, because hydrogen have 3 and nitrogen have 1, makes the nitrogen as the central atom. So this is the skeleton structure. Don't need to draw the lone pair yet. So it's like this. And from what I have explained, that one bonding pair equals to 2 electrons. So we have 3, 1, 2 and 3. So it's just 3 times 2 equals 6 electrons. 6 electron used. So 8 minus 6 equals 2. And then where does the 2 more electrons goes as lone pair? Because you cannot draw it like this. You cannot draw it like this, because it's not the ideal structure. Because we know hydrogen can only have 1 valence electron, not 2. So we draw it like this, as one lone pair lah. So becomes 2 minus 2 equals to 0. Next, the same thing, state the shape of each molecule. So this is trigonal bipyramidal. And we have just to memorize. Next, CH4, we just follow the same thing. My style formula is write the formula. Since it was given, we don't have to think much about it. Know the valence electron. Carbon, we have 4 valence with 4 hydrogen. That means it's 4 times 1 valence electron equals, and then we just add together 4 plus 4 equals 8. Total is 8 electron. And then we draw the skeleton structure. Carbon has 1 and 4 hydrogen. And the shape is tetrahedral. Okay. Next question. Predict the bond angles of each molecule and explain the differences in bond angle. So we have to do 2 things here for all of the molecule. Predict the bond angle for H2O and H3 and CH4, and then we have to explain the differences. So it's a 4-mark question. That means here is 2. I'm sorry. Okay, just forget about that. So we have to know what will happen in H2O. Since the lone pair, they will push the bonding pair and the bonding pair closer because they are stronger. Okay, so if we look at our lecture notes, it will say that lone pair is greater than lone pair bonding pair and greater than bonding pair. So this is the, I will say, the strength, how strong they are. So we have to state the exact, okay, the exact angle. We cannot just say, oh, it's more than 107. Less than 107 degree or something like that, because we have to actually. We just have to say the exact angle. We cannot just say it's less than something or something. So we already predicted the bond angle, and now we have to explain the differences. So the differences is lone pair repulsion greater than lone pair bonding pair. This is the lone pair bonding pair, and the bonding pair repulsion. This is the bonding pair repulsion. So what will happen if one of the forces is greater than the other? This will cause the bond angle to H of the molecule be smaller. So the thing is, state the exact angle. Number 2, state the type of repulsion it has. Number 3, tell what happened. So number 1, we just take the exact bond angle, this one, and then state the type of repulsion. State the type of repulsion. We have the lone pair is greater than a lone pair bonding pair, and bonding pair repulsion. It's I would say it's the same thing for all, but not it's the same lah. There are something you just need to memorize and something you just need to know what will happen. So for NH3, we have to draw. Before all of this, we have to know one thing. Draw the correct structure. Because if we want to know the exact angle, we need to know the correct structure. So this is H2O. So because they will push this one away, causing it to become smaller like that. But this one, because of NH3, they will push this one. But all of this will push each other into like away from them. Hence, they become less than 109.5 degree. But see, they don't have because it only has one lone pair. It becomes the lone pair bonding pair is stronger than the bonding pair repulsion. So once we draw the correct structure, we can know we will know what is the angle and what to explain. So, and then we state the type of repulsion it has. This one. After that, we tell what happened when that bond is there. Same for the CH4. Okay. So, for the CH4, since all of the strength of the bonding pair repulsion are equals. So the bond angle for CH4 is 109.5 degree, and just take the type of repulsion it has. It has the bonding pair repulsion is the weakest, because we know it's the weakest, and this causes CH4 bond angle to be same for all, that is 109.5. I'm sorry, this is the molecular shape, it's not the correct structure. It's called the molecular shape. Correct molecular shape. Next question. The valence orbital of N in nitrogen fluoride, NF3, are hybridized. N uses hybridized orbital to form bonds in NF3 molecules. Identify the hybridized orbitals on N. So we have to look at this question correctly. Identify the hybridized orbitals of N. Identify. We just have to know what is the type of orbital it has. So we know that nitrogen has 5 electrons. Hence, N is on period 2. So, to S to P. And according to Vesper theory, we have to fill in the shell in front of us. That's what I understand. So, it becomes 2S, 2P, 2S and 2P. Next, we just have to combine all of this into one, become sp3. Why sp3? Yes, because it has 3 bonding pair. So this, for me I will just say yes, s p p p, hence sp3. It's easy for me to know lah. And then what happens to the p shell or the p orbital? It's empty. We have to still draw and state that it's empty, just to know that it's empty. It has a p shell, but it's empty. And it said identify. We just have to tell what it has. N atom has 3 bonding pair and lone pair. Thus, sp3 hybrid orbital. You have to explain why it has sp3 hybrid orbital. You just take these 3. It has 3 bonding pair and 1 lone pair. It's simple. Okay, next, determine whether the molecule is polar or non-polar, and then we have to explain the answer. For me, I would prefer to draw everything from start. We know the Lewis structure. We draw the Lewis structure because N has 5 electrons. Fluorine has 7 electrons. But it has 3 atoms of fluorine. So we have total of 21 electrons. We just add this together. 21 plus 5 equals 26. And then we draw the skeleton structure. 1, 2, 3. 3 times 2 is 6 minus 6. We have 20. And then we fill in the valence electron of each. Since fluorine has 7, 1, 2, 3, 4, 5, 6, and then 7 over here. You understand? And then, but we don't need to count for this anymore. We can just forget about this, and this. So it has 2, 4, 6. 6 times 3 is 18. 6 times 3 is 18. So 20 minus 18 is 2. What about the 2 valence? Put up here. Minus 2 equals 0. So it's the correct structure. Next, we identify the class A. It's AB3E. Why AB3E? It has 3 bonding pair. B is known as, for me, I would say B is bonding pair. bonding pair. And the E is for electron pair or the lone pair. Electron pair or lone pair. It's like that. So here's 3 bonding pair, 1, 2, 3. That's AB3 and 1 electron pair, AB3E. The molecular shape is the trigonal pyramidal. The molecular geometry is what causes the bond angle 109.5. To draw now we have to determine its polarity, because the question asks us determine whether polar or non-polar, and then we have to explain. So we know that fluorine is more electronegative, and because it's more electronegative and the charge, the electron will be gathered here at the fluorine, making this one more positive or partially positive. So to draw the electrons going from nitrogen to fluorine, we draw it like this one. This line indicates that it's partially positive, and this one indicates it's partially negative. So we have to draw on all of the bonding pair. Understand? Next, we just state why it's we have to explain why it's a polar molecule or non-polar. So NF3 is a polar molecule because the covalent bond between atoms of different element is polar. Thus the molecule are polar molecule, and the mu is not equal 0. The bond dipole cannot cancel each other out because it's asymmetrical. It's not the same shape because it's all going downwards. If it's CH4, you know it's H, and H, because they are symmetrical. Symmetry, they cancel out each other. Because it's going up here, it's going here, and here. Thus it's non-polar.